Okay, so what we've, I hope this shows up. Actually, you know what? I'm going to make it 200%. So we're going to plot pi times r times the square root of r squared plus 9 over pi squared times r to the fourth.
Yeah.
Starting going, r goes from 0.25 to 4. Okay?
All right.
All right, so let's see what the surface area becomes. Okay, so what kind of shape do we seem to have here?
So it looks like a parabola, like maybe half of one. And the other part's going to go over here, but...
Yeah, I don't think it's actually going to be quite a parabola, but it's a good observation. I'll start at point 1.
No, it's not.
Okay, but in what way is it sort of similar to a parabola?
Well, it is. It's got like these. It's got like a curve to it.
Okay. And what are we trying to find?
We're trying to find the minimum
surface area.
Or actually, we're trying to find the maximum surface area. But for the minimum volume.
Other way around.
Or maximum volume for minimum surface area.
Yeah.
Well, set the volume to be 1.
It's close. So for a given volume, we're trying to find the minimum surface area. And this is a plot of the surface area as a function of r. And so what is nice about this plot as it relates to our problem?
Well, we can tell what the minimum is.
Right. There is a minimum.
That's like over here somewhere.
Okay, so maybe I'll go, what would you suggest if I zoom in around here? What do you suggest I change my range of r
maybe
from?
0.1 to 0.5.
Okay, 0.1 to 0.5.
Doesn't look like we've hit the minimum yet. Maybe we go from like 0.3 to 0.6.
0.3, 0.6.
Still going down.
How about we go 0.5 to 1?
Okay, 0.5 to 1.
Okay.
Oh, sorry. Oh, look at that.
We leveled out around.
Looks like it's right. It's like around 4.
It's weird. It looks like it goes under a bit for some reason.
Well, but that's...
Okay, so where should I zoom in now?
How about 0.8 to 0.9?
0.8 to 0.9. Okay.
So it hits like about right before 0.88.
All right, so give me another suggestion to zoom in.
0.86.
86 to 88.
0.86 to 0.88. Okay.
Yeah.
All right, let's do one more zoom in.
0.875 to 0.88.
Okay, so the curve is getting exaggerated now.
Yeah. But it looks like it's around 0.418.
Yeah. Yeah, so it looks like we found that the minimum value, we'll call it 0.419, really.
Yeah.
Right, because it's 0.4188.
Yeah.
If I zoomed in even a little bit more, 0.877 to 0.878.
It's like 0.8773, looks like.
0.877 2 to 0.8774. So yeah, so we're zooming in, and it looks like we're right around 0.4188. And what were we trying to get below?
3.84.
3.84. So
the hemisphere is better.
yeah, so the interesting thing about the cone is that if we go from, as we said, I'll go from 0.2 to 0. Or to say 3. As we have a cone, we have two variables. So as we change the radius, keeping the volume fixed, we get a new curve. But the interesting thing is, we can't beat the hemisphere.
Maybe it's like harder to make a hemisphere of ice.
Yeah, I think they said that the cone was the easiest shape for like things to make. If you just like start like just piling things on top of each other, they'll naturally form like a cone-like shape.
Yeah.
That was pretty easy to make.
Yeah, and the difference here isn't huge. So the box or the cube had a surface area of 5. The hemisphere was 3.84, and here we're getting down, let's even just say to 1 decimal, 4.2.
Yeah.
So you're going from 4.2 to 3.8. So it's not a humongous difference. So in that case, if it is easier to make, maybe it does save you
a lot of time
overall.
Yeah.
But anyway, so it's interesting. So thanks to Dan Anderson for pointing us to that article. And yeah, it's a fun project.
Yeah.
All right. Good work, guys.